Hi guys, welcome back. Today's lesson we are going to do slope-intercept form of a line. So we are still talking about relationships that are linear. So if we graph them, they'll form lines. It's just a different way of writing it than slope-intercept form. So up until now, everything we've done has been in slope-intercept form. If we wanted to graph a line, we had to put it in slope-intercept form. So we'll start off by kind of reviewing that and putting this particular equation into slope-intercept form. That means we're isolating y. First step is to distribute this 2 when you're doing this. We don't do anything with the left side. The right side becomes 2x minus 6. Now to get y by itself, we just need to move this minus 5, so we're going to add 5 to both sides. That gives us y equals 2x minus 1. Now, this is slope-intercept form. The reason it's called slope-intercept form is because the slope, which is right there, is clearly visible. Slope is 2. Also, the y-intercept is clearly visible. It's negative 1. So we call it slope-intercept form. You know you have it in slope-intercept form if the y is isolated like this and it has this format, and you can easily identify the slope and the y-intercept. Another form is actually this original form when we had y minus 5 equals 2 times the quantity of x minus 3. This right here is called point-slope form. So this is the exact same equation. You might want to jot this down that it's called point-slope form. It's a little bit different than slope-intercept form. It looks different, obviously. We don't have to rearrange it and put it into slope-intercept form in order to deal with this. By looking at it, I can tell the slope, that's why the word slope is in its name, and a point. Now, it could be any point. It's not necessarily a y-intercept like it was before, but I can find a point on this line just by looking at this. We'll start with the slope. We knew from the previous problem when I actually took that same equation and isolated y to put it in slope-intercept form that the slope was 2. That's going to always be the case. This number right here is going to be your slope. It's still what's multiplied by x. So when you distribute that 2, that still becomes your x. So the slope is always going to be right there in front of the parenthesis. So my slope is 2. Now the point that we're talking about, the point is given by the other 2 numbers. Remember that any point on a coordinate grid has 2 coordinates. It has an x and it has a y. The point that's given in this is given by this negative 3 and this negative 5. The only thing is with point-slope form, the point that we're given isn't negative 3 and negative 5. It's always going to be the opposite of whatever that is. The formula actually has minus in it. What that means is that it's not going to be a negative 3 we use for our x. It's going to be a positive 3 that we use for our x. This is the y value of the point. Again, it's the opposite of what it looks like. It looks like a negative 5. It's actually a positive 5 for the y value. So one point on this line is the point 3, 5. So now without even having to rearrange this equation, I can look at this and I can find some information out about it, and I could graph it if I needed to. So for instance, if I wanted to graph this, I don't need the y-intercept. I'm given a point. This point right here, 3, 5, is right about here on your graph. So you can just plot that point right away. That is 3, 5. We know that is on our line. We know the slope is 2, so then we can use the slope. If the slope is 2, remember that means rise 2, run 1. So from this given point, okay, you've got to start at this given point, you go up 2 over 1, up 2 over 1, and you can continue doing that, and that would be your line. So your equation of your line and your graph like this. So point slope gives you enough information to graph it without rearranging it, to identify the slope without having to rearrange it, and to find a point, one of the points on the line. So let's practice that a bit. Oh, before we do, go ahead and you might want to pause this. This is just a review of what we just said. This is point slope form. This is kind of the generic formula for it. It's what it looks like. We plug in numbers for this value, and then of course the slope. We'll have actual numbers in there for that point. The x and the y one just represent the x and the y of a point. And then m, of course, is your slope. That's where the slope goes. M will always be slope when you see the letter m in an equation for a line. M always represents the slope. The x and the y one represent a point on the line. And we still have x and y in our actual answers. So when we write the equation, just like we did in that previous example, like this, you always have x and y because they're variable. They represent all kinds of points that could potentially be on that line. So let's look at another example. So this is a different equation in point slope form. Y minus 4 equals negative 2 times the quantity of x minus 6. So let's identify what we know. We know the slope. The slope is pictured right here. My slope is negative 2. One known point that I'm given by looking at this without rearranging it, we use the information here and here. And remember, it's the opposite of what you think it looks like. So the negative 6 is with the x. That goes with the x coordinate. So it's a positive 6 for that point. And the y minus 4 tell us that we have a positive 4 for the y coordinate. So one point on this line is at the point 6, 4. And then if we did need to write the equation in slope-intercept form, we do what we did at the very beginning of this lesson and we rearrange it. So we'll start off by distributing. I'm just going to come down here and distribute that negative 2 on the left side. I won't do anything on the, on the right side. I won't do anything on the left side. So I'll get negative 2x and then plus, because that's like a negative times a negative, 12. Now to isolate y, to put it in slope-intercept form, that's our goal. We want to get y by itself. We're going to add 4 to both sides. Then we get y equals negative 2x plus 16. So that's the slope-intercept form if you did need to write it in slope-intercept form. Let's try that with another one. So take a pause here, look at the equation in point slope form, and see if you can identify the slope, one point on the line that's given in that formula, and rearrange it so that it's in slope-intercept form. So pause for a second and do that. Okay, so here are the answers. The slope is given by this number right here, so slope is 3. The point is given by the 2 and the 1. The 2 is the x, the 1 is the y, but it's the opposite. So since they're both positive this time, we're going to use the opposite of that. Instead of a positive 2 for x, the x is a negative 2 and the y is a negative 1. So one point that is on this line is the point negative 2, negative 1. I didn't ask you to do this, but if I had asked you to graph it, you start with the point that you know. When it was in slope-intercept form, that used to be the y-intercept, but I can't look at slope form and tell what the y-intercept is. So I start with this point that I do know, negative 2, negative 1. You start there, keep your pencil on that dot, and use your slope to go from that point to the next. That means go up 1, 2, 3 over 1. And that's how you could graph this line in point slope form. Now, the slope-intercept form of the line, I'll show you how that works out. You distribute the 3, so you'll get 3x plus 6 on the right side, and then you subtract 1 from both sides, and you get y equals 3x plus 5. So that's your slope-intercept form. That reiterates that the slope is 3, so there's your slope. And remember, if ever you needed the y-intercept is given in this form pretty easily. The y-intercept is 5. Okay, one more like that. Again, take a pause, look at that equation in point slope form, and try to identify the slope, the point, and rearrange it to put it in slope-intercept form. Okay, so for this one, since the slope doesn't really have a number right here, you have to pretend there's an imaginary 1 in front of the parentheses. The slope does exist. It's a -1. The point that we know, since it has x plus 3, the x will be a -3. It's the opposite of this that goes there. And the y will be a +8. It's the opposite of that goes for the y. So one point on this line is -3, 8. And for this one, the slope intercept form of this line, you have to distribute a -1. So it's -1x minus 3. Then to isolate y, we add 8 to both sides. And we get -1x plus 5 for our slope intercept form. So that's the slope intercept form of the line. The slope is -1. The y-intercept is 5. Now there are other things we can do with slope-intercept form as well, and point-slope form, I mean. It's actually easier to write equations in point-slope form depending on what information you're given. So if I give you this information where I ask you to write an equation of a line whose slope is 6, and it passes through the point 1, 5. Before, if you wanted to put this in slope-intercept form, you had to solve the equation. You'd have to write the equation in y equals mx plus b form. You'd have to plug in the slope. You'd have to plug in the point for x and y and solve for b. And while that wasn't too difficult, now with point slope form, we've got an even easier way to do it. We know where these points, this information goes into point slope form. So remember, I'll just leave them blank. This is the format for point slope form. We have y minus a number equals, that's going to be the slope right there, times x minus some number. Or it could be plus. It'll be the opposite of whatever it should be. This is my x and my y that go into that point slope form. Make sure you're putting the y with the y. So it's not a positive, it's a -5 that goes there. Remember, it's always the opposite. The 1 goes here, -1. And then the slope goes in front of the parentheses like this. So that's it. That's all there is to it. Point slope form, you just have to plug in the point into the formula and plug in the slope, and you're done. If you did need to put it in slope-intercept form, you do exactly what we've been doing. You isolate the y. So in this case, we would distribute a 6 first on the right side, add 5 to isolate y, and that's my slope-intercept form. So even if you're being asked to put it in slope-intercept form, it's a really good idea to put it in point slope form first, especially if you're given a random point and the slope. It's a lot easier to do it in point slope form first, and then you can convert it to slope intercept form if you need to. So let's try that again. So here we have a line with a slope of -1/2, and it passes through the point -2, 3. So you pause the video and try to write that in point slope form, just point slope form. Plug it into that formula. Okay, the way this should plug in is the 3 goes with the y, and it'll be a -3 because it's positive and we do the opposite in point slope form, equals, the slope goes here, and then we'll have x plus 2. Since that 2 is negative, we do the opposite. We write x plus 2. So remember, that's my x that goes there. That's my y that goes there. And then the slope is the -1/2. And then if you needed to convert it to slope-intercept form, after that, what you could do is isolate y. So we'll distribute the -1/2. 1/2 times 2 is 1, so it's -1. And then add 3 to both sides. And that's your slope-intercept form, -1/2 x plus 2. So again, even if you're being asked to put it in slope-intercept form, it might be a lot easier to do point-slope form first and then convert it. So let's see, what happens if we have 2 points? So they're not giving us the slope this time. Well, it's still probably easier for you to go ahead and put it in point-slope form. The only time slope-intercept form is easier is if they give you the y-intercept specifically. These are just two random points. They're not y-intercepts, so it's easier to put it in point-slope form. The only thing we're missing is the slope. We don't have the slope, so we do have to calculate it. But we should remember how to calculate slope. Remember, slope is delta y, the difference in y, over delta x, the difference in x. So we take our y's and we subtract them. -1 minus 3. We take our x's and subtract them. 5 minus 4. That gives me a -4 over 1. So my slope is -4. That's all I really need to put it into point slope form. Now remember, I have to have a point showing in this formula. So since I've been given 2 points, you could pick either one. It doesn't matter which point you choose. I'll write it both ways with each point. It doesn't matter which one you use, so they'd both be correct. So we'll start with this one. If I use the 5, -1 as my point in point slope form, it would look like this. Y plus 1, use the opposite of that, equals -4, x minus 5, use the opposite of the x. If you choose the second point, 4, 3, then your equation would look like this. Y minus 3 equals -4, x minus 4. Both of those formulas are correct because that point that we plug in there could be any point on the line, so we can pick either one. And again, we do slope-intercept form by isolating y. So again, it doesn't matter which formula you use, the top one or the bottom one, it'll give you the same slope-intercept form. So either way, you can pause this and convert it to slope-intercept form now, and I'll put it up. Regardless of which equation or formula you used, your slope-intercept form of the line would be y equals -4x plus 19. So that's your slope and your y-intercept. Your slope is -4, we knew that already. Y-intercept is 19. Okay, one more example with 2 points. Okay, pause the screen and try to write the point slope and the slope-intercept form for these 2 points, a line passing through these 2 points on your own. Pause now, and I'll put the answers up in a sec. Okay, first step is to get the slope. So in order to get the slope, we subtract the y's, put that on top, -1 minus 1. Subtract the x's. Make sure you have, when you do the x's, 4 minus -3. That ends up being 4 plus +3. So on the top, I have a -2, and on the bottom, I have a +7. So that's my slope. It is a fraction. If you got your slope wrong, you might want to pause it again and redo your point slope and your slope intercept form, because if your slope wasn't right, the rest of it wasn't going to be right either. Okay, so using that slope, we are going to have to deal with some fractions here, but that's okay. Pick either one of these points. I'll put both of your options for point slope form. If I use the first point, the 4, -1, I'll have y plus 1 equals, slope is -2 over 7, and x minus 4. The 4 goes there. Or, if you use the other point, again, you'll have y, but this time minus 1, equals -2/7, x plus 3. Both of those are correct. Now when you're converting it to slope-intercept form, you're going to have to multiply some fractions. It doesn't really matter which one you use, and one's not going to be easier than the other. I'm going to use the bottom one. So the first thing I'm going to do is distribute -2/7. This will be minus 6 over 7. If you need to do that 2/7 times 3 off to the side, looks like that. You just multiply straight across the top. So it's a -6 over 7. All right, then we have to add 1 to both sides. Now, when adding and subtracting fractions, we need to get common denominators. So when I'm doing this right here, I'll just move that off to the side. I have a -6 over 7 plus 1 can be written as 7 over 7. So when I add a negative 6/7 and a positive 7/7, I get positive 1/7. Negative 6 plus 7 gives me a positive 1. The denominator stays the same. So your slope-intercept form of this line is this. Okay, so that's what point-slope form is and how you can use point-slope to write equations of lines and to graph lines.